Okay, so now we'll try to use the GM by ID to find the optimum value for which we can get a gain of around 60 dB or more than 50 dB. So 60 dB means the gain should be around 1000 total gain of two stages multiplying. So if my first stage will give a gain of 100 and second stage if I assume gain will give a 10, then what will happen, this first stage I have to make the gain around 100, and for that I need a I need the GM by GDS to be high for driver. Okay, and according to that we can put it for our PMOS load. Okay, so let's see here. I have taken this NMOS 1 volt. Okay, so I have taken the variable. I have already mentioned all these things in my previous videos, and I am doing it again, and I have taken variable as width and length. So, and I have taken the variable for VDS and VGS. Although source I have taken here ground, but our source will be at 250 millivolt. Okay, so we'll see. First we'll check with the ground, and we'll again recheck. We'll make it a recalculation if needed with the source. Okay, so here you can see all the calculation, and I'm varying my VGS. Okay, and I'll check the length for which we'll get a gain of 100 at least GM by GDS. Okay, so I'll do a parametric analysis. I'll sweep the length. I have taken the width as 5u. Actually I can put it as not with the 5u but minimum width, no problem with that one. So I'm putting it as minimum width 120 nano, and I'll run for all of these things. Okay, you can see from here GM by ID versus V overdrive, GM by GDS versus GM by ID, FT versus GM by ID, all this thing I will plot. So we'll do a parametric analysis with length, varying length. First I need the gain. Okay, gain is my priority. I need a 60 dB of gain or more than 50 dB. So I'll vary it from 100 nanometer to 1U to check whether my gain is within that limit, because if I increase this length, the resistance value will increase or GDS value will decrease, and the chance of increasing the gain. Okay, so let's do a sweep. So for gain we have to look for the GM by GDS graph, this one, and versus GM by ID it is there. So I'm copying it to another rectangular, and we'll see. I'll make a vertical marker at 15. That is for proper saturation. Okay, so my gain is 107 for this length, that is 600 nano. Okay, so from 600 and 600 nano it is giving me length 107 gain. Okay, and I'm assuming 10 at the next stage, so 107 into 10 it will be around 60 dB I'm guessing. So 600 nano is good enough, we can take that. Okay, also for that one we have to see this current because we have 10 microcurrent. Okay, so 600 nano, sorry, it is at 15. I need 5 micro. Okay, so current depends upon, of course, upon the W also, W by L. So for 600 nano it is now some 368 nano. Okay, so we found our minimum length for which, because that is what parts needed, that is I am taking 600 nano as my length. Now what I'll do, I'll vary my W width. So minimum width is 120 nano, and I'll vary up to 10 U maybe. Okay, and number of steps 10. I'll not make it linear, I'll make it auto. Okay, 10 steps. Let's see. So frequency of 10 megahertz we needed. Okay, and current of 5 micro. First I'll check the current. Copy to new window. 5 micro current at 15. So for 5 microcurrent I need the W of around, let me see, this one would be good, around 2 micro. So around 2 micro. Okay, so it is 2 micro, 2.28, around 2 micro, 1.4 to 2 micro. I'll do again, but before that I'll also need the frequency. Frequency. So what, 15. I'm getting most of the frequency good, so you can see at 2.28. Okay, so frequency is good, 10 megahertz it will give. After also, if we move our CC to inside, so the frequency will be within that range. Okay, so this is higher frequency, so I am guessing we will get that, get our frequency. Okay, so you can see VGS minus VTH, we overdrive at 15, we overdrive is 100 millivolt. Okay, so we overdrive is 100 millivolt we are getting. Okay, so what is the VGS? Why not the VGS? Okay, this VGS is there, so VGS will be, okay, VGS will be 292 millivolt or 290 millivolt. Okay, so let's put that value, that is 2 micro, and I check again. 2 micro and check again. Okay, so VGS, so if I put here 15, I should get all the values. Okay, frequency code, VGS is 292, 100 millivolt of we are getting. P overdrive, VGS minus VTH, good. Okay, 917 megahertz frequency, current is 6.6. Okay, 106 is good, and this one is I divide W. Okay, so fine, we can use it. And 292 plus 250 millivolt, so it will be 540 millivolt, around 550 540 millivolt VGS is required. Okay, I'll test that one. Let's test that one in our current mirror stage. Okay, now I'll remove this one. Okay, and I'll put a, so this will be 2U6. Okay, Okay. This one, this one. So input I need 250 plus that one 250, 250 plus that is 540, around 540, 550. Let's take it 550 millivolt. Okay.